to my instructor, Professor Dr. Mohammed Abdiladi, and my assistant Huzam. My name is Putai Che. I'm a software engineer student at Üniversitesi with student ID 240504505. Today, I am very excited to present and demonstrate my project 2 for the programming 2 projects. The primary objective of this project is to deploy a time-ready Java Swing application that solves a 2x2 system or linear equation using camera rules. Beyond just solving equations, the application also visualizes the intersection of three specific line segments to determine the particles or a triangle. In this project, I have applied modular programming principles by separating the logics using interface and visualization into 4 distinct classes. Like linear equation.java for the core mathematical logics, line panel.java for using input components, graphic panel.java for the graphical representation, and main.java, which integrate everything into a functional GUI. And as you can see in my NetBeans, I have organized this pie under the project 2 bucket. Now I will walk you through the implementation of each class, starting with the linear equation. Now I am declaring the 6 private Java data field A, B, C, D, E, and F. This variable will store the coefficient of our equation as defined in the assignment construction. And next, I will create a constructor with 6 arguments: is type A, type B, type C, type D, type E, and type F. This constructor will allow us to pass the specific value for our lines when we create an object of this class. Is this star A equal A, this star P equal P, and C for C, D for D, E for E, F for F. That's it. And then next part is very important part of this class is that is solid methods. So I will write this important part now. As required, each check it 80 minus VC is not equal to 0. If it is 0, the line are parallel and there is no intersection points. And then finally, I am implementing the case A and case Y method. I am using the access formula provided in the assignments. X equal to 80 minus PF over 80 minus PC, and Y is equal to AF minus EC over 80 minus PC to return the coordinate of the solution. So that completes our linear equation class. This logic will be the foundation for calculating the intersection point of our 3 lines to form a triangle. In the next part, I will show you how I use this in my main logic. I will explain the line panel class. This class is custom UI component extension panel. Its main purpose is to provide a visual input area where the user can enter the static and edit coordinate for each line segment. Here, I have declared for the data object to store the value for x1, y1, a2, and y2. I made them public so that our main class can easily access this value later to perform calculation. In the constructor, the class state a title and for integer value as argument pass. I add a GLibet to display the title set at line 1. Then I initialize each data with the default value using string.value of. Finally, I use the add method to arrange label like A1 and Y1 next to their represented data. By using a modular approach, I can simply create 3 instance of line panel in the main window for our 3 lines. This following the principle of modular programming make the code clean and easily to maintain. I will explain the panel class. This class is responsibility for the visual output of our project is extension panel, which provides us with a camera to draw our geometry, shape, and coordinate axes. Inside the class, I use a 3D editor array and named D to store the coordinate of our three-line segment. That's the data methods. What is this coordinate from the main class? Update our internet array and then call rebate. This ensures the correct is updated instantly whenever the user clicks calculate. The actual variety happens inside the main component methods. Pass line to create the X and Y axis. I have added a 20% offset from the edge to make sure the axis and the organ are clearly visible on the screen. To draw the three lines, I used a followed with an array of color red, blue, and gray. A very important logic here is how I made the Y coordinate. Since Java coordinate system step from the top left, I subtract the Y value from 300 to play the grade. This made it appear like a standard mathematical grade that we are all seeing. This class efficiently turns our numerical data into a clear visualization, allowing the user to see the graphical part by the intersection line. I will present the main class. This is the heart of the project where I bring together our logic input panel and the graph visualizer into a single application window. In the instructor, I set the window title with my ID. And the panel layout using Buddha layout. I use a guide layout for the draw section to start our three-line panel, line panel object, and the calculation button neatly. To create a professional interface, I place the input panel at the node, the drawing camera in the center, and the square event report area at the side. This ensure the user can see input, the grade, and the numerical results all at once. And now I will code calculation path. Now I'm writing the calculation path. I use a triangle plot to handle any input errors. Inside, I will try the A and Y coordinate from our three-line panel objects L1, L2, and L3. I use integer dot %int to convert the data input into integer array C1, C2, and C3. Now I will code the C1, C2, and C3. This one is I pass this coordinate to our camera, which is an instant or graph panel by calling set data. The graph will automatically we draw the three lines with their specific color. Now I need to compare each line segment into a standard linear equation part ax plus by equals e. Following the intersection logic from the assignment, a is calculated as the difference in y axis y1 minus y2. B is the difference in x coordinate a2 minus a1. E is the constant value calculated as a 81 plus by1. And then I use the linear equation class to find the three intersection points B1, B2, and B3. For example, equation 1 solve the system between line 1 and line 2. I use the isolate method to check it an intersection axis. If true, we try the 8y coordinate using cat 8 and cat y and format them into our verbal string. So I am writing about linear equation 1, equation 2, and equation 3. And these are I copy paste from equation 1 to equation 2 and 3, and I renew all the things because equation 1 and 2 and 3 are not equal, but it is same. That's why I am doing like this. I am doing it handily. Finally, there was a display in the web area. If the user enter non-numeric value, the catch plot will display an error message instead of crashing the program. At the bottom, the main method simply launch our application. This completes the logic and demonstrated on my project too. This is my code, so let me show you how it can. Now, at the top we have 3 input panel create using the line panel class, and now I will click calculate triangle property. Immediately the curve panel presents the 3 lines, the red, blue, and green line represent line 1 and 2 and 3 represent line, and at the bottom the purple area displays the intersection point of the triangle B1, B2, and B3. B1 is the intersection of line 1 and line 2. B2 is where line 2 and line 3 meet. B3 is the meeting point for line 3 and line 1. If I enter the invalid input select letter and click calculate again, the system catch the expression and display error input numeric value. This ensures the application is reproduced and user-friendly, and everything is working perfectly as required by the assignment guideline. Thank you for watching my presentation.